Welcome to The Explainer. Today, we're diving into something that is literally rewriting the rulebook on human aging. We're jumping straight into the deep end of what I like to call the longevity iceberg. You know, on the surface, it looks like a straightforward story about the latest weight loss crazes. But underneath? Oh man, there is a massive hidden world of metabolic science, artificial intelligence, and a high-stakes race for synthetic designer drugs. Let's get right into it.
Let's kick things off with a question that honestly sounds a bit like science fiction, but it is rapidly becoming science fact. What if the world's most popular weight loss drugs were actually hiding the secret to human longevity? I mean, we've all heard the massive buzz around medications like Ozempic and Wegovy, right? They've completely revolutionized how we treat type 2 diabetes and obesity. But here's the twist. They're acting almost like a Trojan horse. We invited them in to help us burn some fat and manage our blood sugar, but scientists are now realizing that these exact same compounds might actually have the power to significantly extend our human health span. To wrap our heads around how a simple weight loss drug could actually help us live longer, we have to talk about the true enemy of aging. It's a concept called inflammaging. Basically, this is a chronic, low-grade inflammation that essentially drives biological aging and all those age-related diseases. Think of it like a persistent, smoldering fire somewhere in your body. Over time, this elevated baseline of inflammation contributes heavily to things like cardiovascular disease, metabolic dysfunction, and just general cellular decline. It is literally one of the most consistent features of getting biologically older. And guess what? This is exactly where our Trojan horse begins its attack.
Now, what's really interesting about this slide is the sheer breadth of these effects. If you look at the areas highlighted, the heart, the kidneys, the vasculature, these are all packed with GLP-1 receptors. So while these drugs were originally designed just for metabolic balance, clinical trials are showing us that they are systematically cooling down that inflammaging fire across multiple organ systems. They're improving how our blood vessels function, and they're protecting our cells from the inside out. It turns out these drugs are doing way more heavy lifting than anyone originally thought.
So the absolute crucial takeaway here is that we are essentially attacking the established biological hallmarks of aging. We aren't just talking about burning belly fat anymore, folks. These GLP-1 agonists are systematically dismantling the very processes that make us biologically old. They're reducing chronic inflammation. They're actually reversing mitochondrial dysfunction by boosting how our cells control quality. They're modulating cellular autophagy, which is just a fancy way of saying they help our cells clean out their own trash. They even protect against cellular senescence. Those are those stubborn zombie cells that refuse to die and end up causing tissue damage. And on top of all that, they've been shown to enhance stem cell survival. I mean, it is a full-scale assault on aging.
But the longevity iceberg goes even deeper. If we zoom out from the gut and the heart, we suddenly find ourselves on the neuroprotection frontier. We're looking directly at the brain. It turns out GLP-1 receptors are scattered all over regions that are absolutely critical for learning and memory, like the hippocampus. This opens up this fascinating, almost unbelievable possibility of preventing cognitive aging and neurodegenerative diseases. But scientists, they aren't just stopping at metabolic drugs. They are actively hunting for parallel compounds that can aggressively protect our neural wiring as we age.
A really perfect example of this parallel hunt is an experimental compound called P7C3A20. Coming out of some incredibly complex screening efforts, this drug is an absolute powerhouse of neuroprotection. What it basically does is enhance the survival of newly born neurons right there in the adult hippocampus. So it doesn't just put a shield around the brain, it actively supports the cellular energy metabolism of these highly vulnerable brand new cells. In preclinical models, this has actually been shown to protect against age-related cognitive decline and even preserve spatial learning. It's a totally distinct yet highly complementary mechanism to those metabolic drugs we were just talking about. Now you might be wondering, wait, how on earth are we finding all these incredible compounds so fast? Well, this brings us to a completely different kind of revolution. Historically, human-driven drug discovery and clinical trials, they could easily drag on for 15 to 20 years. But today, artificial intelligence has entered the chat. AI-designed clinical candidates are hitting phase 1 trials in just 12 months. And for novel senolytic compounds, remember those drugs that clear out the zombie cells? Machine learning is identifying those in mere weeks or months. The sheer mind-bending speed at which AI is compressing decades of traditional chemistry into literally a few weeks is just entirely unprecedented.
Generative AI now sits right at the center of this whole process. It's continuously analyzing these vast, incredibly complex datasets. We're talking genomics, proteomics, metabolomics, and massive troves of electronic health records. The AI integrates all of this data to accurately predict biological age and literally monitor how it responds to different interventions.
So instead of relying on a human researcher's serendipity or lucky guess, the AI is identifying completely new therapeutic targets and molecular patterns that human minds would simply never be able to spot on their own.
Take a platform like AgeExtend, for example. It's an AI designed explicitly for discovering geroprotectors, which are basically compounds that slow down aging. What's absolutely fascinating here, and honestly maybe a little spooky, is that these AI platforms can accurately identify known anti-aging compounds without ever having been trained on them. It uses machine learning to analyze a molecule's bioactivity, predict its toxicity, and figure out how it works, all driven by computational creativity. We're living in a totally new paradigm where generative models are proposing entirely novel molecules designed specifically to make us live longer, healthier lives.
But this is where we have to take a hard step back from all the utopian science and look at the real-world implications. 800 to 1,200 euros. That is the staggering monthly cost of GLP-1 therapies in many European markets right now. And the pricing in North America? It follows similar, if not even higher, premium trends. For a long-term or even lifelong longevity intervention, this introduces a pretty harsh reality into the economics of aging. You have to ask yourself, who actually gets to benefit from these mind-blowing AI-driven breakthroughs? And that brings us face to face with the very real threat of a two-tiered longevity system. On one side of the wall, you have the heavily regulated medical market. To get these drugs covered by insurance, you're facing strict physician oversight, you need documented metabolic disease, and you have to prove you've failed lengthy lifestyle interventions first. But on the other side, wealthy individuals are completely bypassing that system. They're buying extra years of healthy life off-label, paying those premium out-of-pocket prices with zero medical supervision and zero coverage barriers. The utopian promise of this science is violently colliding with the harsh reality of health economics.
And the disparity, it doesn't just stop at the pharmacy counter, because these AI tools are available to literally anyone with enough computing power. To really put this into perspective, think about this. Where a skilled underground chemist might previously have conceived of a handful of structural analogs, a generative model can propose thousands of candidate structures overnight. That is a chilling realization. The exact same generative chemistry being used right now to cure Alzheimer's is currently being weaponized by clandestine chemists to flood the global black market. We are actively watching the rise of an algorithmic black market. It's completely unregulated and it is wildly unpredictable. AI is being used as we speak to rapidly invent novel synthetic opioids and cannabinoids that effortlessly bypass existing legal frameworks. And we're not talking about your typical cheap street knockoffs here. These are highly complex, AI-designed structural variants with completely unpredictable potency. They are utterly confounding emergency room doctors and forensic chemists who, ironically, really only have the tools to identify human-invented drug signatures. It's this dark shadow economy operating right alongside the greatest medical breakthroughs of our time.
Which leaves us with a profound dilemma that we really have to answer. Will we democratize longevity? Are we going to implement equitable access so that everyone can actually benefit from these extraordinary molecular discoveries? Or will we just allow an algorithmic black market and a purely wealth-based medical system to dictate who gets to live a longer, healthier life? The science of human health span has arrived, and it got here way faster than anyone predicted. The only question left is, who is it for? Thank you so much for joining me on this explainer, and I'll leave you to think on that.